So this week's lesson is on transformations. Transformations are a way to move polygons from one location to another. There are three main types of transformations. The first type is called translations. These are also known as slides. And it's called a slide or a translation because it literally just goes from one position and it slides to another position. It does not turn, it doesn't flip. It only moves by sliding left to right or up and down. So if this was the original position, we call this the figure, and it translates to the right. We call the position that it ends up in the image. So it starts at the figure and goes to the image location. The second form of transformation is a rotation or a turn. So again, if we have the same shape here, this triangle, it can turn or rotate. And in this case, it's rotating about this corner right here. So if I were to put like a thumbtack right in that corner of this triangle, and then I sort of spun it like a spinner, but a quarter turn clockwise, it would end up down here. So right now it's pointing off to the right, and if I rotated it or turned it, this would swing down here. Almost as if it's like a clock. Imagine this line here is pointing at the 3 on a clock. And then in 15 minutes, the hand would be down here pointing at the 6. The third type of transformation is a reflection or a flip. And that's where you take your figure and you literally flip it over to another position. Now it could flip this way, left, right. It can flip from top to bottom, or it can even flip over on a diagonal. This one will be flipping left to right. So again, this is the figure, and this is the image over here. So it will be flipping over an imaginary line right here. So here's the first form of transformation. It's called the translation. And this is again when a shape moves in straight lines, either left, right, up, or down, without turning or flipping. In an example here, we can see two shapes, well, one shape that's been translated, and we have an underlying grid. Now these grids are really important. They help us figure out how far the shape is moved. So the figure, again, is where it starts. So this here's the figure. So we're starting with this polygon here, this shape, and it says it ends up over here. This is the image. Okay, so if it's going to translate from here to here, you have to count the squares. And what you do is you pick one corner. It could be any one of these vertices. And then you want to figure out how it gets from that vertex to the corresponding vertex on the image shape. So you just want to make sure that you don't count, say, from here and go to this corner, because those are two different corners, right? If I'm picking the top right corner of the figure, I have to figure out how does it get to the top right corner of the image. Okay, so you first obviously have to move right, and then you can go down, or you can go down first and then move right. It doesn't really matter which order you do it in, as long as you get there. So this example shows moving right first, so I'm going to go 1, 2, 3, 4, 5 squares to the right, and then 1, 2, 3, 4 squares down. Yeah, and then there's this thing here called a translation arrow. And a translation arrow just shows again that we're starting with this figure and we're moving in this direction to the image. So to get from the figure to the image in this case, we have to translate 5 squares right and then translate 4 squares down, or 4 squares down, 5 squares right. Next we have rotations. Now they're a little bit trickier than translations. When a shape moves by turning, either clockwise or counterclockwise, that's a rotation. Now we can describe the rotation in terms of what direction it moves in, so again, clockwise or counterclockwise, and how far it turns. Okay, so if we're moving clockwise, if you just picture a clock, and we know that a clock ticks this way, it goes around the clock, starting at 12, 1, 2, 3, all the way around, back to 12 again. So if the shape rotates in that direction, then it's rotating clockwise. If it's going the opposite direction, going backwards on a clock, then we call that counterclockwise. And then the second part is how far it rotates, so the amount of rotation. Now, here's some examples. I've got a car that's pointing up, so imagine this is a clock. It would be pointing towards 12 o'clock, and we're saying this is the initial figure position. Okay, then we're going to rotate it to its new image position. Now, if it just turns a little bit, so it's pointing right, that means it turned a quarter turn because it's gone a quarter of the way around the circle to the right. Now, again, if we're going from 12 to 3 like this, that's going in a clockwise direction, right? It's going in a normal direction that a clock would go in. If it started here in the figure position and ended up like this, well, then it's done a half turn. And you could say it's done a half turn clockwise, or you could say it's done a half turn counterclockwise. They would both end up in the same image position. And then the last type of amount of rotation that you typically would see is a 3/4 turn. So we start with the figure pointing up at 12, and then the image, it says here that it's pointing now to the left, pointing at 9 o'clock. And the arrow tells you that it's going this way, it's going clockwise. So that means it's gone, well, 1/4, half, 3/4 of the way all the way around the circle. So that would be a 3/4 turn clockwise. Now you could also end up in this position by doing a quarter turn counterclockwise. And this initial one over here, I didn't mention, but you could either do a quarter turn clockwise, or if we started in this position, we could do a counterclockwise, a 3/4 turn counterclockwise. So I'd go backwards, 1, 2, 3, and it would end up in this same position. And then these are just different images. They won't always be on a nice little shape like this, showing you the quarters. So you just have to be able to imagine there's a clock behind that shape. So when you see the initial figure and then you see the image, you can imagine that there's a clock. And so it's pointing at 12, now it's pointing at 3, 6, or 9. So here's an example of a polygon that's being rotated. Now we've got the figure, so this is the polygon or the shape that we're starting with, the figure, and then this one says it's the image. So it's going from this position over to this position. Okay. The pink arrow here, just like a translation arrow, this is a rotation arrow. So it's saying that it's starting from here and it's sort of going up and to the right to this position. Okay, so what I like to do is whenever I have a polygon, I'm trying to figure out, okay, well, how far has it rotated? Is it going clockwise, counterclockwise? Well, the arrow tells you right away if it's going clockwise or counterclockwise, and because it's going in this direction, like a normal clock would, then that's clockwise. But to know how far it's gone, it's a bit trickier. I always look for a line or a side in the polygon that is either pointing at 12, 3, 6, or 9 o'clock. So this one here, I can see the bottom line here, this side here is pointing across to 9 o'clock. So that's something I can sort of keep my eye on as it rotates. So as it rotates upwards clockwise, that line right here now becomes this line. So it's now pointing at 12 o'clock. So it started pointing at 9, now it's pointing at 12, so that's really just in a quarter turn rotation. So I would say that the figure did a quarter turn or a quarter rotation clockwise, and then it's really important to say where it's turning from, or where it's rotating around, and it's rotating around this vertex here. It's labeled A, or it can be called turn center. So as it's rotating, you have to imagine that there's like a thumbtack or a little pin that's been placed on that corner of the shape, so that then when you rotate it, that corner will stay in the same spot. It's pinned down. So as this shape rotates a quarter turn clockwise up to the image location, that bottom corner hasn't changed. It's still in that exact same location, but everything else has rotated around it. Now you could also get to this image location by going backwards, by going counterclockwise. So remember that a quarter turn clockwise is the same thing as a 3/4 turn counterclockwise. So this is pointing at 9 o'clock right now. So if it went 3/4 turn counterclockwise, this side would go, well, a quarter turn counterclockwise, so it would point down at 6. a half turn counterclockwise, it would point over at 3, and a 3/4 turn counterclockwise, it would be pointing up at 12. But usually when we're describing rotation, we just pick the rotation that requires the smallest amount of rotation. So it's easier to go from the figure here to the image just by doing a quarter turn, right? To go all the way around backwards, it would be quite a lot. So always just pick the shortest distance to the image. And lastly, we have reflections. So when a shape moves by flipping or mirroring itself, it's a reflection. We use a mirror line, as you can see here, in between the figure and the reflected image to show how far it is flipped. The figure and reflected image are equal distance from the mirror line. So this figure here and this image, they're exactly the same distance from the mirror line. Like this image isn't way up here, or it isn't touching the mirror line. You can tell that they're exactly the same distance apart from it. Okay, so each vertex from the figure has a corresponding vertex on the image that are equally distant from the mirror line. So for example, this vertex here, well, its corresponding vertex on the image is this one, and they're each just one square away from the mirror. Right, imagine that you are standing in front of a mirror. If you're very close to the mirror, then your image will appear to be very close, right? But if you're standing further back, like this point over here, then the image will look like it's further away. Okay, so when you're drawing an image of a figure as it's being reflected across a mirror line, the easiest way to do it, instead of just trying to sort of freehand draw it, just pick a vertex, find out how far away it is from the mirror, and then go that same distance across on the other side of the mirror and just put a dot down. Okay? Then you go to the next vertex from the figure. You count how many squares it's away. So this one's 2 squares away from the mirror line. So I'd go 2 squares away on the opposite side of the mirror line to draw my image vertex. And then you just keep on doing that. You draw all of the vertexes, and then you connect the dots, just being sure that you're connecting the dots in the correct order. If you have several vertices, it's easy to say skip over a dot or maybe do it in the wrong order. So just make sure that you connect those dots. What can make it easier is as soon as you've drawn those first 2 vertices, connect them. And then draw the third vertice, and then connect that third vertice with the line that you drew. That way you know you're going in the correct order. Now, the most difficult part about reflections is when the mirror line is on a diagonal. So they can be horizontal, vertical, or diagonal. One of the ways that I find you can find the reflection or the image being reflected across the mirror line, you can do this for any mirror line, whether it's horizontal, vertical, or diagonal, is if you actually have it on a piece of paper, you can fold that paper so that the crease is right on the mirror line, and then when you fold it over, you'll see the shape, the figure, on the other side, or you'll see what it should look like. So if you start to draw your shape and you're not sure if it's quite right, then you can just fold that piece of paper over, and if the figure, when it folds over, if it lines up perfectly with the shape that you've drawn, then you've done it correctly. Now you can also just fold it over before you even draw the shape, and then on the blank side, if you can see through, you can sort of trace the shape out. But there is also a way you can do it without folding. Just like when the mirror line is horizontal or vertical, you can count how far away each vertex is from the mirror line. It's just a little bit trickier because you're on a diagonal. But for this one, for example, if I picked this vertex, I can see that it's one sort of diagonal square away from the mirror. So if I want to draw this corresponding vertex in the image, I would go 1 square diagonally to the mirror, and then I'd go 1 more square diagonally, and I'd put a vertex right here. And then my next vertex, if I chose this one, I want to count to see how far away this is from the mirror. So I would just go on a diagonal. So I go 1, 2, 3, and see how the mirror line goes right, it sort of cuts the square in half. So it would be 3.5 squares. So what I would have to do is count 3.5 on the other side. So that's half, 1.5, 2.5, 3.5. So if this graph paper kept on going up here, my dot would be somewhere up here. And then this one, you can see it's 1 square away, so 1 square away on the other side. And this one, if I counted the squares, would be 1, 2, 3, 4 squares away. So I'd go 1, 2, 3, 4 squares, put a dot, and you just connect those 4 dots, and you'd have your reflected image.